So example 5, we got this word problem. We're talking about a science class where Abby mixes a fixed amount of baking soda with different amounts of vinegar in a bottle capped with a balloon. She records the amount of time it takes the gases produced by the reaction to inflate the balloon. From her data, she has created a function to model the situation, and it gives us the equation for that, which is good. We don't have to do anything to build an equation out of that. They gave it to us. But this equation says X is how much vinegar we're putting in there, or the quarter cups of vinegar. And then T of X, the whole equation, when you plug that in, that gets you how many seconds it takes to inflate the balloon. That's what this equation does for us. It says A part, so big long word problem to tell us in A part to say how long would it take to inflate the balloon with 5 quarter cups of vinegar. Where does the 5 go?
For X.
Yeah, you put it in for X. So we're going to do T of 5. Now, we could manually put this in, like write it out, negative 0.12 parentheses 5, close parentheses cubed, and work it out individually, like type it all in the calculator. But I'm going to graph it with my calculator and let it help me evaluate that and get the number for that. So just using the graphing calculator, again, if you don't have one of those, you need one of those. That's going to help you with this today. So I'm going to go to my calculator. I'm at y equals, and I'm typing in that equation. Negative 0.12 x raised to the third plus x squared minus 3.38x and then plus 13.16. Now, if all I had to do was A part and plug in a 5, I probably wouldn't do it this way. But I know on B part, I'm going to use this graph a little bit more. So graphing it really does help. And honestly, I've got to where I use this way of evaluating stuff because it's easier. So I'm looking at the graph of that. So we see, part of the graph of this cubic polynomial. And they want to know what's happening at 5. So 1, 2, 3, 4, 5. And up here, 1, 2, 3, 4, 5. It's somewhere around 6 seconds out of there. But I'm going to get the exact number by hitting trace 5 and enter. And that gets me that with 5 quarter cups of vinegar, it takes 6.26 seconds for the balloon to inflate. That's what this tells us, based on the function they gave us and the information they gave us about that equation in the word problem. So big long word problem to just plug in a 5, but we get 6.26 seconds. So that's what A part asks us to do. So has anybody ever done that, like use baking soda and vinegar to clean anything or something like that? I know, like my wife had a skillet that we were out of power one day, and I took it outside and used it on the grill to fry some eggs or something like that, and it turned it black on the bottom where the gas, and you couldn't just like scrub it off. So she said, well, let's just sprinkle some baking soda on it and then pour vinegar on it. And it's amazing. It just took it off. It cleaned off real quick. That chemical reaction is what makes that happen. And it creates these gases and byproducts and all that fun stuff. If you get Miss Madge or Miss French to do that experiment with you in class, it's pretty fun. All right, B part. So this is another, using the same information from the big long word problem. B part says, what do the x and y intercepts of this graph mean in this context? And then it says, do those make sense? Okay, so this is a little bit adapting real world thinking to the math here. So on our graph, we know that it crosses the y-axis somewhere up here off the screen. I want to know what that y-intercept is. So how do I find a y-intercept? Kind of the same way I did A part. What do I trace? Yeah, trace 0, enter. And here is my 0 cups of vinegar, and then 13.16 is what? seconds. Okay, so the y-intercept is at 0, 13.16. What does that mean in this context? It means what? What does that mean in this context? So we put some baking soda in the bottle, and now we're pouring vinegar in there. How much vinegar at the y-intercept am I pouring in? What does x represent in our word problem? So if x is, what's x in this ordered pair? So how much vinegar am I putting in there? None. Yeah, I'm not putting any vinegar in there. But it then says that the y-intercept is 13.16. So what's it saying about the balloon and the 13.16? After adding 0 cups of vinegar, it takes how long for the balloon to inflate? Yeah, 13.16 seconds. Now, here's where common sense has got to come in. Is that possible? No. Why not? 0 cups of vinegar. Yeah, and with no vinegar in there with the baking soda, what's going to happen?
No chemical reaction.
No chemical reaction, which means the balloon's just going to
No movement whatsoever.
be there. Yeah, it's just going to be on top of it. The baking soda's going to sit there and not react. So does this make sense?
No.
No. So in this case, what does that tell us about Abby's equation? Maybe it's got some issues with it. That's what that tells us out of this. So the making sense of the problem is the fact that, hey, this really doesn't make sense. It would be very unlikely for the balloon to inflate with no reaction. That's our making sense of that problem. Okay, so that's the y-intercept. It also asks us in the B part there to find the x-intercepts, which we did this yesterday as well. And when I look at that graph, I can see there is one x-intercept here. I need to find that. How did we find that yesterday? Second trace, 0. And then it asks for a left bound, so that means it needs to be where? Yeah, somewhere above the x-axis here. So I'm going to move my x over where it gets a little closer to that so I can see it. There's my cursor. That is definitely above the x-axis. And then it asks for a right bound, so I need to move to the right until I'm below the x-axis. Out of there as I'm traveling along. That's far enough. Hey, Coach. Yeah. Great. Need you for a second. And now it asks me to guess. So I'm just going back close to where it crosses. I don't have to get it perfect. I just need to tell it, hey, go somewhere close to there. And I hit enter. And it tells me that 6.5, we'll go 2 decimal places, 6.59, and y equals 0. So that's my x-intercept. 6.59 and 0. So that's it. What does that mean in the context of this problem? That 6.59 is what? How much? How much vinegar?
6.59.
6.59, not just cups, but quarter cups. Will inflate the balloon in how long? Ooh. 0 seconds. Is there any chemical reaction that can happen in 0 seconds? No, it's going to take some amount of time. It may be really fast, but it's, yeah, it might be like 0.0001 seconds, but it's going to be some sort of time it's got to take place from when I pour the vinegar in there on top of the baking soda. It's got to take some time to inflate the balloon in some way. So does this make sense? No. Okay, so what's that tell us about Abby's equation? It's probably got some issues to it. It may not be the best equation for this situation. It's what what happened is Abby was using a stopwatch to time how long it took the balloon to inflate. And if you've ever timed anything, there's a human element there where you may be late starting it, you may be late stopping it, you may be early starting it or early stopping it. So her data that she collected to create that equation may have been a little bit off, causing her equation to be wrong out of that. So that's what it means to us, is that that doesn't make sense, that time can't be 0 for a reaction. We know it's going to take at least some part of a second to make that happen. So there we've taken and found the intercepts that we talked about yesterday with just plain equations, and we've applied it to a situation. And here, we decided, hey, common sense tells us this really doesn't make a lot of sense that happened that way. So that tells us, hey, that's probably not the right equation. All right, let's try it here. Danielle is engineering a new brand of shoes. For X shoes sold in thousands, a profit of, they give us an equation, that many dollars in 10,000s, so that's in 10,000s of dollars, will be earned. How much will be earned in profit for selling 1,000 shoes? Okay, so for A part, what are we plugging in there? Back up. We were snoring, so yeah, you were sleeping.
I'm not the one sneezing.
All right. So, key thing here is that it says for shoes sold in thousands and profit is in 10,000s. So, what are we plugging in for X for 1,000 shoes sold? For 1,000 shoes sold, how many X's is that?
1.
It's only 1, yeah. So we're trying to find out what P of 1 is. Even though they said 1,000, up here in the problem, this is the trickery that happens in this, is that they put that in, X is represented in thousands. So we're going to find out what P of 1 is. I'm going to do it the same way we did it in the example 5. I'm going to let the graph do it, because that's easier than working that through there. Not that this one is terribly hard, but it does tend to get a little easier when you do it this way. So let me get my equation. Don't screw that up. Negative 3x raised to the 4th plus 4x raised to the 3rd minus 2x squared plus 5x plus 10. Okay, I'm going to hit graph. And I want to know what's going on at 1. So 1 is right here. So we know it's somewhere way up there. So we're going to make some profit. So I'm going to hit trace 1. 14. Okay, what does that mean for our profit? Profit would be 14 times 10,000, right? What is 14 times 10,000? $140,000. That's a nice profit. I could handle that. That's almost what I make a year. Close. That's a joke. It's nowhere. That is not even close. That mine has got an extra 0 on there. Well, no, the decimal's in a whole different place.
Right.
Yeah, we don't make that much. It'd be nice if we did, though. Tell your board members we need more. All right. B is going into that and saying, okay, well, what do the x and y intercepts of this mean for that? So let's find those. I'll start with the y-intercept because that's what we started with on example 5, and then we'll do the x-intercepts. So y-intercept, ordered pair is going to be, what's the x value going to be? 0. So that means we're selling how many shoes? 0 shoes. Ooh. Okay. Do we expect a profit if we don't sell any shoes? No. Okay. So that's the common sense part of this. So on my calculator, I'm going to hit trace 0, and I got a 10. So that means that when I selling 0 shoes gives $100,000 profit. That doesn't make sense, does it? Yeah, that would be maybe we're cooking the books there, as they call it, when you're not exactly got legal.
Basically, if you're selling
business.
0 shoes, then you get $0 profit.
You should, yeah. You shouldn't make any money. You actually should be in the negatives, right? Because if you're selling none of the shoes, but you made them, it cost you some money to make those shoes, right? That's kind of what we see in most business practices. That you got to put some money into it to get some money out of it. Well, so that doesn't make sense. So let's communicate that. So we should not have a profit for no sales. That's a good way of saying that. So x-intercepts. Now, when we look at the graph, what do we notice about our x-intercepts here on these? How many x-intercepts do we have? 2 of them. Okay. What's the first one, the furthest to the left? Just reading it left to right.
Isn't that like how much money she has lost?
Well, what does x represent?
Shoes sold.
Shoes sold. That's what the word problem told us. Is shoes sold. What kind of number is this? Can we sell negative shoes?
No.
No, either we got shoes, we sell no shoes, or we sell shoes. There's no negative shoe action happening, I wouldn't think. So do we even need to find that x-intercept?
No.
I wouldn't think so, because I mean we're not going to sell negative shoes. We're going to sell shoes. We're not going to sell negative shoes. So that would be like us making the shoes, they're perfectly fine, and then just chunking them in the trash. And I don't think we're going to do that out of that. So we just need to find this one over here. It looks like it's pretty close to 2, but I'm going to use that 0 tool on the calculator to get the exact amount. So second trace, go to 0, and I'm just going to move over there closer to it. Just keep moving your arrow, and you'll notice the ordered pairs down here. So that you're left bound. We know it's somewhere close to 2, so here I've got kind of close to 2. Hit enter, move past 2, hit enter, and then I'm going to move back, kind of close to that. And it is not quite 2, it's 1 point, we'll go 2 decimal places again, 1.91. So selling, multiply 1.91 times 10,000. 1, 2, 3, 4. Would be 19,100. Is that right? 1, 2, 3. $100 or 100 shoes. No, back up. Multiply by 1,000, not 10,000. Sorry, because that's X value. Y values were 10,000. So 1.91 times 1,000. 1,910 shoes sold gives $0 in profit.
That's a physics stealing.
Do what? Does that make sense?
No.
No, we should have some sort of profit because when we sold what was it, 1,000 shoes, we made $140,000. Here we sold more than that, almost twice as much, and we ended up not making anything. That doesn't make sense. So, selling 19,000 or 1,910 shoes should give some profit. That starts making sense of that. So what do we know about our equation? It's probably wrong based on some data, or we're not really good business people, and we don't know how to price our shoes very well.
They either got robbed or
That's something like that had to happen, or maybe our warehouse got flooded or something. I lost a bunch of shoes in a fire or something like that. I don't know. Something weird happened there. But making sense of the problem is one of the things in Algebra 2 that they ask us to try to push toward is making sense of that. Does the answer you get make sense in a real world context? And here we can see some scenarios where it's not making a lot of sense out of that. So on the, I think there's another page there, concept summary. Here is that stuff about the turning points. Remember, those are the maxes and mins, the turning points, and we found those using the calculator. And then down here is kind of another way of saying all of this stuff, where if the degree is odd and it has a leading coefficient, then the ends look like this. If the degree is even and it has a positive leading coefficient, the ends look like this. If it's odd degree and a negative, they look like this. And then if it's even degree and a negative leading coefficient, they both point down out of that. Now, on your practice that I handed out there, mark out the first column. That's pretty much what we've been doing all the time. 13, 14, 15, 16, and 17. Mark all of those out. And then you're starting there on 18. It says put that in standard form. If there are pieces that have the same, like x cubed, like on number 18, you've got two pieces that have x cubed, combine them with whatever operation is there. So it's negative 3x cubed and a positive 8x cubed. So put those together as a 5x cubed out of that. So if there's common fact or common terms, put them together. Like terms is what that leads to. So 18, 19, and 20, all you're doing is putting it in standard form, which means start with the highest power of x, go down, and then name the degree, the number of terms, and the leading coefficient, which we did examples like yesterday very directly, just like that. On 21, 22, and 23, it asks you to use the leading coefficient and degree to determine the end behavior. When you write your end behavior, do this, like as x goes to negative infinity, what does y do? So write it like this, because this is how you're going to have to do it on the quiz. This is how it's going to have the answer choices on the quiz. Is like this. X goes to, and that means, and maybe it's better if I put the L. This is left. This is right.
Thank you.
Maybe that helps. Okay. So on 21, 22, and 23, it's already in standard form. All you need to do is look at the degree and the leading coefficient. Match it up here. Use this to help you. If you're welcome to come take a picture of this with your phone or whatever so that you got that to help you study by or use as you're going there. Then 24 and 25, it says estimate the intercepts and turning points for the function. That's using the graphing calculator. Go 2 decimal places if it's not a nice number. So if it's a decimal, go 2 decimal places. Round to 2 decimal places on those. 26, we did an example very much like that. 2 examples very much like that. 27, relative minimum. That's a minimum on the graph. And then 28, 29, a couple of word problems out of that. Key formula for volume. Remember that volume is length times width times height. That's the formula for volume if you don't remember that. You'll need that for 28. And then the rest of them are pretty straightforward. There, leading coefficient is all you're doing on 30. 31, it asks for a polynomial. Standard form can have how many terms? Yeah, pretty easy stuff. So not a ton of problems to do here. Not a lot to do on some of the problems. Some of them is a little bit more than others. But working through that, you've got the rest of the time today to do that. So that's about 50 minutes. So plenty of time to work on that and get a good start on it. Tomorrow we'll do 3-2. Which is adding, subtracting, and multiplying polynomials, which is not hard. And then Thursday we'll do a recap, and then Friday we'll quiz over 3-1 and 3-2. Okay, and that'll be our first week of the new 9 weeks out of that. So don't get in a hole here the first week. Get your assignments done on time and turned in. Okay, that's fine.